Okay, so everything seems to work well. Once again, welcome everyone, and thanks for being here online to the Research AMA. As you know, every month we publish a blog post from the Risk Interoperability series. Last week we published a blog post, CrossChain Update Transaction. Today we are here on stage with Maxime, research scientist, and Jan, head of research, to answer all your questions based on this blog post, and not only. So please make sure to send all your questions in the chat. I would like to invite Jan and Maxime on stage.
Thank you very much for the introduction, Monica. First of all, to get started, Maxime, maybe you want to give a short recap, just in a few sentences, of the blog post.
Yeah, of course. Yeah, thank you, Monica, for the introduction. So our latest blog post was about CrossChain Update Transactions, and we will call them CCUs for probably the rest of this talk. So the CCUs are a type of transactions that we use for cross-chain communication. As you know, everything that happens on a blockchain has to happen through a transaction. If there is no transaction, nothing happens. And so if we want to have communication from one chain to another chain, then there is a sending chain which will emit some messages, and the receiving chain wants to receive those messages. And so this CCU is the transaction that you use to include those messages in the receiving chain. And additionally to the messages in the CCU, we add information that guarantees the fact that the messages are valid and have been included in the sending chain. And this information is gathered in what we call a certificate, and those certificates are regularly created on sending chains, and then they are used on receiving chains to validate the messages. So that's it. The main idea is that this transaction is like a big envelope or a big box in which we put the messages, and then this is used to include the messages in the receiving chain.
Yeah, thank you. I also can recommend everyone to open the blog post. There are some nice pictures, and I think that also help to understand this context more intuitively and more visually. Also now go a bit more deep into the topic. We also prepared some questions just to get started. So the first one is, do we have to use cross-chain update transactions for all communication? So as a user, can I not just send a message directly from one chain to another chain? Mm-hmm. Maybe you could elaborate a bit on that.
Mm-hmm. So that would be the dream somehow, that magically messages can transmit from one chain to the other. But this is not possible for a very obvious reason. If you think about, let's say, a transfer, you want that the tokens are subtracted from the sending chain and then added in the receiving chain. And so you want to make sure that the message was actually included and executed on the sending chain. And this is very hard to achieve, or almost impossible to achieve, if you just throw messages around randomly. So the way that we chose was to have those messages included in this CCU, and this CCU has the additional information required to make sure that everything has been included in the sending chain. It has the slight advantage also that being an envelope in which you can put many messages, then you can validate the fact that they were included in the sending chain at once for many messages. Like if we wanted to do the somehow other way of messages being directly included without a CCU, then every message would have to carry a lot of additional information to every time prove that, yes, I was included in the sending chain, and yes, I was executed correctly. And this is extremely cumbersome and makes cross-chain communication much slower. And for this, the CCUs are really good.
Yeah. Then some other detail, which is maybe for which you need to go into quite detail to understand it. Is it possible to send cross-chain updates directly from one sidechain to another? Maybe you could explain a bit why this is not directly possible.
Yes. So as you said, the answer to the question is not really. You can't send a cross-chain update directly from one sidechain to another in the Lisk ecosystem. The communication always goes through the main chain. The reason for this is twofold. The first and most important reason is an ecosystem reason. We want that if you create a sidechain, you connect to the main chain, and then automatically you are connected to the whole ecosystem and you can communicate with every other sidechain. And so this way of routing the cross-chain communication through the main chain is really practical for this. Otherwise, you would have to create channels between your new sidechain and every other sidechain to be able to communicate with them, and that would be really, really cumbersome. The second reason why communication goes through the main chain is that all the message fees are paid in Lisk with the LSK token, and the main chain needs to be able to somehow follow those LSK tokens in the ecosystem, and always needs to be able to know, okay, this sidechain has so many LSK, this sidechain has so many, and if fees are used from to pay for a message from one sidechain to the other sidechain, then the main chain needs to maintain this balance. I would say that those are the main reasons.
Yeah. I think we by now already have quite a few questions from the community coming in.
Nice.
And so we could move to one of those. Maybe you want to get started on one of them?
Yeah, sure. Let's maybe take the first question we had from Tom Plum, Andrew, where he says that in the blog post, we use the example of a cross-chain token transfer. Is that specifically for LSK, or does it also work for sidechain token? So maybe asking about the communication of a sidechain token and being able to transfer sidechain tokens from one chain to the next.
Yeah, I would think if it's also possible the same way with sidechain tokens as with Lisk tokens.
Yeah, the Lisk token in the ecosystem doesn't really have a special place except for paying for the message fees. So whatever is possible in terms of transfer for the Lisk token is also possible for other kinds of tokens. Yeah. And maybe the second question also from Andrew. The notion of CrossChain Update sounds a bit like DeFi protocol, where Lisk would be the intermediate between two trades like Uniswap and Pancakeswap. Would you say that this is rather the correct notion and the correct idea to have in mind?
I mean, if you look at Uniswap or Pancakeswap, they would run on the same chain. So in principle, an Uniswap contract could call directly a Pancakeswap contract and the other way around. But as far as I understand, those two protocols, they work quite independently. Of course, you can swap tokens with one of them and then move them to the other DEX to exchange them there. If you want to achieve the same thing in Lisk, you could have one Uniswap sidechain and one Pancakeswap sidechain. And in both of these sidechains, you would have this functionality of a DEX. So you could exchange tokens or add tokens to a pool for generating some revenue. And then if you want to transfer some tokens that you exchanged in the Uniswap exchange, you would go through the main chain and move them to the Pancakeswap exchange to further trade them there. So in that sense, like the DeFi protocol would transfer to the Lisk protocol. But cross-chain updates are more general. You cannot just apply them to this concrete blockchain application, but these cross-chain messages, they are generic messages. They can have as parameters, they can transfer arbitrary information. So they are not restricted to just token transfers.
Yeah, definitely. And one difference that we have in the Lisk ecosystem compared to, for example, the Ethereum ecosystem is that each application is running its own blockchain. And so you don't have scalability issues as you could have in Ethereum. Like both of the Pancakeswap and the Uniswap token would have their own blockchain, and they could define their own block production mechanism. Maybe one needs to have shorter block time, I don't know, something like this, which is not possible on a smart contract chain.
Yeah, so if Uniswap has super many transactions, the Pancakeswap sidechain would not be affected. And maybe the Uniswap sidechain decides to have then larger block size or quicker block time just to cope with this transaction load, which would be quite flexibly. And but the other sidechains, they don't have to deal with this increased size of data or block size.
Yeah, and something we can say with our CCU method is that in the example you just mentioned, where one sidechain decides to update its protocol, all the other sidechains don't have to care. For them, the interaction or the communication will stay exactly the same. They won't even notice that that the Uniswap sidechain, for example, underwent some kind of update.
Yeah.
Maybe the next question I can actually take for myself. It's quite specific. It's from Jure from the Musti team. And he asked about a situation in the blog post where one certificate is not included because a newer certificate is added. And he asked, how does this work? Why is it this way? And does it mean that some certificates are never stored? So he's talking about a specific example that I wrote down in the blog post. So in the blog post, I have a communication example between two chains. And in one of those communication steps, one certificate is skipped and not included in the CrossChain update. So how does this work? And what is it about? So the way to answer this is that you have to separate the receiving chain and the sending chain, and understand that the certificates are used on the receiving chain to prove the information from the sending chain. But you don't need to prove strictly every step. It's like on the sending chain, let's say you create 5 certificates which certify 5 steps of advancement of this sending chain. Well, if during 2 of those steps there were no cross-chain messages, then maybe you don't really need to certify this advancement. And then maybe between this certificate and the next one, there are like few messages that you want to certify. Well, with our certificate technique, you can directly jump to wherever you want. So all the certificates are still included in the sending chain. They are there and they are available if you need them. But on the receiving chain, you don't need to include all of them if somehow they don't bring you information that is required.
And the key property why this is possible is that this Outbox route that you have, it always authenticates all the messages that have been sent by the chain so far. It doesn't just authenticate the last messages since the last certificate, but all of them. So you have if one chain in all of its history sent 1 million messages, this Outbox route will authenticate all of them. But this is not a problem because you have this nice property of Merkle trees that the proofs are logarithmic in the total size. So even if you have 1 million elements in this tree, the proofs are still very small. And then you just need to prove that all the last messages that are newly added and that are not known to the other chain, that these are the correct ones. And so this way, every certificate certifies the whole history, and that's why you can just skip over intermediate ones.
Yes.
And maybe this also connects to the next question, which is like, does the outbox or inbox size have a maximum? So there's no limit on the size, and so you can have 1 billion messages from one chain, and what the main chain has to store is not the whole history of messages. It only needs to store the latest outbox and some path, which is an append path, which is logarithmic in the size of the overall messages. And so if you have, let's say, 1 billion, it's still just 30 elements roughly. And so just on the size of the outbox or inbox, there's no limit.
Yeah. Maybe a small technicalities that we could add on this is that, as you said, the outbox root authenticates the whole outbox so far, but you don't need to have a proof against the whole size of the outbox every time you send a cross-chain update. Like if you have already authenticated the first billion messages, then when you send your next cross-chain update for the next 10 messages, your proof will be extremely short just for those 10 messages, because the billion first ones are already in the receiving chain, in the Merkle tree.
Yeah. Yeah, because the chain will just add the messages and then check if the new outbox root is what it expects. So you don't actually need any Merkle proof in that case, right?
Yeah, exactly. Yeah. Further questions. We have many questions. We're very happy about it. So, should we answer this question from Presmer? Is there some kind of relayer to send those CCT or cross-chain transfer maybe here, or what we call CCU, the cross-chain updates? If yes, how is he incentivized? How are they incentivized? So here we have, there are two parts to including CCUs. There is a first part, which is the most like the final part, is the CCU contains all the messages that need to go to a certain chain. And for all those messages that will be applied directly, they have a message fee, and this message fee is assigned to the relayer. The second part, which is the routing part, the relayer needs to include the CCU in the main chain, and then all the messages are forwarded to their receiving chain. There, the relayer is not incentivized in our model so far, but we are looking for like methods to incentivize them. It's not too difficult to create incentivization, but we want to research the best way to do it. One ad hoc incentive that exists for posting those CCUs is that you want your cross-chain communication to happen. So if I'm on a sidechain and I send a message to the main chain, and my wallet tells me, do you want to finalize the sending, which would mean including the CCU, then I will just do it because I want my message to be forwarded, and I don't need anybody else to do it for me. And this is one of the nice properties of these certificate mechanisms, is that all the certificates are included in sending chains, and they are not reserved to a certain class of relayer. You don't need to register yourself as a relayer or pay some registration fees. Anybody can send the CCU transaction, and everybody has the information required to send the CCUs. So if I want to be very quick with my cross-chain transfer, I would send it, wait for finalization, and then send the CCU that corresponds to it, and therefore it will straight away be included in the receiving chain.
Yeah, maybe to add on this, of course, this mechanism that Maxime says is if you want have yourself an incentive, you can do it yourself. Of course, somehow the issue is that for this mechanism, if I send a cross-chain message and then I just wait for someone else to do that work for me, for the next guy who sends the cross-chain message. And so this is a bit then a tragedy of the commons problem. So that's why we want to also develop a more sophisticated incentivization mechanism that is incentive compatible. And as well for the case where you need like these cross-chain updates at least every once per month, just for the liveness. So even if there are no cross-chain messages, you need these updates. And for those cases, you also need some kind of incentive. You could say that the validators of the sidechain, they together have an incentive to submit those. But then again, this is a question, who does it? Like if everyone is lazy, then there's always one guy who has to pay this extra fee on the main chain. And for this, we basically already have everything in place. So like if you submit a cross-chain update to the main chain, there's a message that will be sent back to the sidechain, which says, okay, this cross-chain update was submitted by this person with that fee. And so then the sidechain could trigger some automatic kind of reimbursement. But here you want somehow a nice mechanism that cannot be like tricked easily, that someone can get too much for their work or get too little for their work.
Yeah. And this will be in our future research starting roughly now, and will come out in the next batch of libs.
Yeah. So this is something that we will look at as part of one of the future research topics. Should we then move to another question? We have here another one by Jure from the Musti team. So this is a longer one. So right now, Lisk defines a standard with cross-chain messages stuffed into cross-chain updates with a certificate. Do you think that standards will arise to specific cross-chain messages within the ecosystem too? If so, what kind of standards would you like to see? And then in brackets, I assume this question is for this question that all information about custom modules and transactions is transferred within the cross-chain messages. Is this a correct assumption?
Mm-hmm. Okay, so to answer on standards for cross-chain messages, definitely we will see standards come up. Already from our side, we have 3 modules that define standard messages. We have some messages in the base interoperability module. For example, the one that Jan just mentioned, which is called the CrossChain Update Receipt, which is sent back to the sending chain and announces this CCU was posted by this guy paying this amount of fee. And the interoperability module actually defines a few other standard messages that are used by the interoperability module. And next to it, we also have 2 modules that we published in the forum during the last month, which are the token module and the NFT module. And those also have standard messages to transfer token and NFTs from one chain to the next. I fully expect that from the community side, standard modules will also appear, and we will have a library of modules that are you can just basically include them in your blockchain application if you need them, and those will include standard messages that can be directly used somehow out of the box, but which which standard will arise on which standard modules will arise, this is up to the community. From our side, we think that tokens and NFTs are very important. So we will have them somehow in the base SDK, but we don't have other base module planned so far.
Yeah, and maybe to add to this, so the interoperability messages and the token messages is something that every chain has to support in the ecosystem, whereas NFTs is something optional. So if you don't want NFTs on your sidechain, you don't have to support them. And if someone then sends an NFT to your sidechain, this will just fail. And if there's enough fee in that such a message, it would actually return an error message, and the user could get credited the NFT back. But if not, then it's just gone. But of course, like with a good front end, this should never happen. The front end should check for the user to not send NFTs somewhere where they are not supported.
This is the same as if you send tokens to an address that doesn't have a private key or something like this, and they can't be accessed anymore.
And in general about standards, of course, like every time two sidechains communicate with each other via cross-chain messages, they need the same kind of aligned understanding of these cross-chain messages for it to work. So if you send tokens, just tokens from sidechain to sidechain, you can use the token module. But if you want any like custom messages that trigger custom logic, you need to develop like a communication standard just for these two sidechains. And maybe you think this is a nice effort. It's maybe interesting for the broader community. And in that case, it would be nice then if it's established as a ecosystem-wide standard and well documented. And we will also look more into how we facilitate something like this, where there's a resource with a repository or something like this, with like the kind of communication standards that have been established so far in the ecosystem.
Very good. And we have a last question from Jure Musti, who was very prolific. So the blog post describes.
I think we covered that one already.
Yeah, it's not ticked off, but we did cover. So we covered all of those. Okay. So maybe we could. So here we have this question about finalization. So for CrossChain updates, it's very important that messages are final, because a message that is not final is at risk of being reverted if, for example, the chain was on a fork. And so CrossChain updates only accept messages which have reached the finalization threshold. And one question that can arise then is, what happens if suddenly there are not enough delegates and the chain cannot finalize any blocks anymore? Are the lists that I had on this sidechain lost forever, or would they come back? And I think here we had the answer last month in the registration blog post, is that we need to have a heartbeat CCU every month. So every sidechain needs to send a CCU every month to the main chain. And this implies that the sidechain must finalize block every month. If there are no final block, there is no communication. And if this heartbeat CCU is not sent, the sidechain is terminated and every user can recover the tokens that they have in this sidechain. This includes a list token, but also includes the tokens from other sidechains. Of course, you can't recover the token of the sidechain that is being terminated because they come from this sidechain. So that wouldn't make any sense. But you can recover all your list token, you can recover all your NFTs that are from other sidechains. And in that regard, if a chain stops finalizing blocks, basically you have to wait 1 month, the sidechain is terminated, and then you can recover everything. So your tokens are not lost.
Yeah, maybe just to mention the small print here is that you need the data from the sidechain. So for the recovery, you need to prove that your account had a certain balance. And if you just don't have access to this, so like if the sidechain would disappear without leaving any trace from anyone, then you will, on the main chain, you will just have this one hash and you can't generate the proof. So you need like the data availability. But if the sidechain is sufficiently decentralized, there are enough people running a node, then there should be someone who has the data and can generate this proof for you. No. Just to, the small print can be sometimes important, just to mention it. Yeah, I think this was pretty much all questions that we had about CrossChain updates. We then also could go into a bit of a different topic, which is more recent, which is the Lisk Mainnet migration. And yeah, probably most of you have been following it closely. And so probably there are also some research questions regarding this topic. Just to get started, question from our side, maybe Maxime, you could explain how is the migration process going at the moment, and is it fully completed?
So the migration process went very well. And we had last week, 1 week of a bootstrap period where the new deposit system was not yet active. So we were forging blocks with the new protocol, but still with delegates from the previous version of the blockchain. And from this weekend, I think Sunday night, and the new deposit is active, and the transition was extremely smooth. Everything went very well. So now we have finalized blocks. We have all votes being effective. We have standby delegates being chosen every round. And I think it's going very well. We see more and more votes being cast, and the threshold to be an active delegate rising. It's still much lower than what it was in the previous version of the protocol, but this was expected. But overall, I would say it went very well, and the chain is running very smoothly. And from your side?
Yeah, I think in general, I was also like thinking that it, like from the protocol side, everything went super nicely. They were like with Lisk service on. There were some issues which are now resolved, and like also the transition now, which happened to now this new delegate selection, which happened from Sunday night to Monday, went also very smoothly. I remember Monday morning, I was waking up. First thing, I was going on the Lisk scan and checking are the delegates being selected regarding the new system, what's the voting situation. Yeah, that was very nice to see. Also, I mean, the voting process at the beginning, it seemed like a bit slow. After a few days, you thought, with 100 Lisk, you can become an active delegate. That's a bit little low. But I think most people were just waiting until the very end, just to to surprise maybe, and just shortly before the migration, suddenly the threshold to become active delegate really rose up. And I think Monday morning we shortly discussed it in the research team, was 33,000 LISC was kind of the threshold. And this morning it was suddenly 70,000. And I expect that also once exchanges open withdrawals, maybe more people will be staking. Maybe also some people have their LISC in a hardware wallet and are waiting for that to work. And then even more people are staking. But yeah, it's kind of nice to see the research, like how it works out, is being used in practice. Yeah.
Yeah, and staying on the new depots, we have this question about the voting behavior and how do we think it will look like long term? What would be the long term distribution? And I have to say that this is a very interesting point because there is the theory of what should happen, what would be the optimal. And maybe I can just say a word on this. So every active delegate gets to forge in every round, but standby delegates only forge proportionally to their vote weight. And so there is a balance because if it's too easy to be an active delegate, so if the vote weight is mainly in standby delegates, then it's extremely profitable to just somehow combine your assets with another standby delegate, become active, and this way you increase the threshold needed to become active. And so in theory, the equilibrium would be that basically every active delegate has a similar vote weight and that the two standby slots also have a cumulative similar weight. So let's say if you need 200,000 or 300,000 LISC to be an active delegate, then we would have 600,000 LISC voting for standby delegates. So this would be what we call Nash equilibrium in game theory. However, on top of this, you have a whole human layer, which is extremely interesting to observe. And there, I don't really know what will happen. I suspect that there will be a bit too much standby weight, just because as standby, it can be difficult to meet other standbys and like say, okay, now let's combine our forces to become an active delegate. And so probably we will have a bit too much standby weight compared to the minimum weight needed to be active.
Which is nice for the decentralization of the network. Like if
nice.
more people run a node and earn some rewards for doing it. Yeah. And right now we have, I think, what were the latest numbers? Around 11 million LISC are staked. I think in 2.0 at the end, I think the amount of LISC being used for voting was like 55, around 50 million LISC. So I think there's still quite a lot of room. It will definitely increase a lot more. Just takes a bit of time. And yeah, the prediction when we were writing the lib was to have around 500,000 LISC for one slot, which is like if you have 50 million and you expect it to, like Maxime said, in this equilibrium, expect the delegate weights to be roughly the same, then it would be around 500,000 per delegate slot or active slot. But there's then still quite some way to go. So yeah, also curious how this will be evolving over time.
But it's true that the last voting mechanism was less committed because you didn't need to lock your tokens and the delegates didn't need to self-vote and lock their tokens.
Yeah.
So maybe we will have a bit less total vote weight.
And also with exchanges, which still have quite a significant or which have quite significant holding in the network. I think some exchanges in the end participated in votings, others not. And I guess that's also a big factor, like how will this work out with the new DPoS? Will more exchanges offer like a staking service for Lisk as a service for users and also participate in DPoS, or they will stay out of this? Yeah, that can just make a huge difference.
Mm-hmm. Yeah, definitely. I see that we have another question regarding CCUs from Future Wind, saying in the future phases, do we foresee that this CCU lib is being used in the Bitcoin blockchain? So yeah, maybe I can start on this one, and then you tell me what you think about it. So this relates to connecting to existing blockchains and using our developed technology of CCUs to connect to other blockchains. And there is two big categories of blockchain we can connect to, because some blockchains like Ethereum have some smart contract capabilities and have some somehow computation capabilities on chain. And those are much more limited on a chain like Bitcoin. And so I think the way we will bridge to those two categories of chain will be quite different. On a chain like Ethereum or some other chains which have some smart contract capabilities which are powerful enough, it could very well be that we create a direct communication channel, and so that you can use information from the Lisk blockchain directly on the Ethereum blockchain to get Ethereum and to exchange Ethereum and Lisks. That could very well be possible. For Bitcoin, it's a bit harder because the compute capabilities of Bitcoin are much lower. And so for this bridge to happen, and here I'm really speculating, and because this needs to be researched further, but probably we would have some kind of intermediary chain. So some kind of bridge chain which would use the technology available on Bitcoin and bridge it to the Lisk ecosystem. But this is very speculative. So what would you think about it?
Yeah, I agree with this, and I also think like in Bitcoin, it is basically impossible to do a hard fork nowadays, I guess.
Yeah.
So you won't have new protocol features, but just have to work with the existing protocol, which is very limited in that regard. So you cannot introduce like a new protocol that would be needed to utilize something like CrossChain Updates directly. And then, I mean, approaches like wrap BTC, which I haven't studied in detail, but my superficial understanding is that you basically have a multi-signature wallet on Bitcoin, and then you have on Ethereum, you have like some collateral. So everyone who has a key on Bitcoin of this multi-sig wallet has also collateral in on Ethereum, and then you this way the protocol is secure, because if like someone on Ethereum or one of these multi-sig participants would do something malicious, they would lose their collateral. Mm-hmm. And I guess something like this you could, as you said, also do for Lisk, that you could have a sidechain of I don't know, like a certain number of where a certain number of, doesn't have to be the validators, but a certain group of people have collateral on the sidechain, as well as hold a multi-signature account on Bitcoin. And then you have to keep those two things in sync. Like as soon as there's Bitcoin incoming, okay, create some wrapped Bitcoin in the Lisk sidechain. This wrapped Bitcoin would be the same as any other token in the Lisk ecosystem, could use the existing token standard and be transferred in the ecosystem.
Yeah, definitely. So it looks like we're reaching the end of our question list. Should we wrap it up here? Yeah.
Yeah, it seems like that's all the questions that we received. yeah, I would suggest we wrap it up here. Thank you very much for all the nice, interesting questions. And yeah, see you in the next AMAs. Thank you.
Bye-bye.
Bye.